Okay, now we'll have a discussion on polymorphism. So we will start with what is polymorphism and how polymorphism is achieved in Java. So polymorphism is one of the feature of object-oriented programming. So in the previous session we had a discussion about different features of object-oriented programming. We started with what is an object, then we discussed about what is object, what is class, and how it is created in Java. Then we moved on to what is an encapsulation and what is an abstraction and what is an inheritance, right? So likewise, polymorphism is one of the feature of object-oriented programming, and this polymorphism feature allows the programmer to have a single interface with the different implementations. So which means that in Java you can have a single method which may have a different implementation. So that is known as polymorphism. So as a developer you can have a single method with a different kind of definitions. So there are different type. There are two types of polymorphism is there in Java. So we will see what are the types of polymorphism and how we can implement it during our development time. So in Java there are two types of polymorphism: compile time as well as the runtime. So we'll start what is compile time polymorphism and what is runtime polymorphism. So in compile time polymorphism, your compiler knows that which method implementation to be executed. So in compile time polymorphism, you can have a different implementations for a single method, and during the compile time itself your compiler knows that which method implementation you are trying to invoke, right? So that is known as compile time polymorphism. And how the compile time polymorphism is achieved in Java, which with the help of overloading. So there is a concept in Java overloading. With the help of method overloading, we can achieve compile time polymorphism. So what is meant by method overloading? So method overloading, which means that you can have a single method signature, single method with the different arguments. So which is also possible in Java. In Java programming, you can have a single method. You can have a single method which carries different kind of arguments. So that is known as method overloading. So in method overloading, the method signature is going to vary in the part of arguments alone. So now I will show the demonstration of how method overloading is achieved in Java. So I'm going to create a separate class candidate. I can go with an employee. So I'm going to have an employee class. Inside that I'm going to have a method display employee, and to define employee of a particular class I have to define certain properties. So I'm going to have name of the employee, and I'm going to have a salary of an employee. So I have created two parameters to represent an employee. So inside display employee, I'm going to have a signature. It is going to display employee. That's it. Then I'm going to have another method in the same signature. So I'm going to overload a method. So I'm going to create a method with the same signature, but the only difference is I'm going to change the argument type. So here I'm going to have an argument, and here I'm going to print the argument name. So here, then if you wish, I can create one more method signature where I'm going to print name and salary. So here I have 3 method implementations with the same method signature, right? So here I'm going to print name and salary. So this is known as overloading, right? So to demonstrate this, I'm going to have a test class. I'm going to create one more class, test. So I'm going to name it as test employee. So inside that test employee, I'm going to have a main method. So here I'm going to create an object for an employee, and I'm going to invoke display method. So I'm going to invoke display method without any argument. Then I'm going to invoke display method with the name. Then I'm going to invoke display employee with a name with a salary. So here we have invoked 3 different methods with the same method signature. So we'll see what is the output of this code. So here the first print the first display employee method, the employee is getting displayed, and the second method we are simply printing the name of the employee, and for the last print we are displaying the name as well as the salary of an employee. So inside employee class, if you look at the method signature, the return type is same for all the 3, and the method name is same for all the 3. The only difference is number of arguments as well as the types of argument. In the first method there is no argument at all. In the second method we have 1 argument. The third method we have 2 arguments, right? So the understanding for method overloading is, so in method overloading, method name should be same. So these are all the restrictions for applying method overloading. Method name should be same, and the return type of method also should be same. So these are 2 basic restrictions for creating a method which applies method overloading. So method name should be same, and the return type of method should be same. The only difference is you can have different argument type, or you can have different number of arguments. So whenever you try to apply method overloading, you have to remember that in method overloading, the method signature, the return type and method name should always be same. The only difference is the argument type as well as the number of argument. So this is how method overloading is done. So the method overload, with the help of method overloading, we are achieving compile time polymorphism. Why we say compile time polymorphism? Because during the compilation itself, your compiler knows that which method you are going to invoke. In the first line, we are going to invoke a method which does not have any argument. In the second line, we are going to invoke a method which accepts 1 argument. So in the third line, we are going to invoke a method which accepts 2 arguments. So the compiler knows that what type of method implementation you are trying to invoke, right? So the idea behind the method overloading is the method signature, like return type and method name, is same, but you can have a different implementation, right? So in the no argument constructor, I have an implementation, and in one argument method, I have different implementation, and in two argument method, I can have different implementation. So that is the speciality of polymorphism. You can have a single method with the different implementations. So that's about compile time polymorphism. Now we'll move on to runtime polymorphism. So the runtime polymorphism can be achieved in two different ways. So either you can achieve runtime polymorphism with superclass reference, as well as this can be applied with overriding. So there are two ways of implementing runtime polymorphism. Right. So in runtime polymorphism, there is another concept comes into the picture for implementing, that is overriding. So we'll see what is overriding first, then we'll move on to how overriding can be achieved, can be used to apply runtime polymorphism. Then we'll move on to what is superclass reference, how it is being created, and how superclass reference is used to implement runtime polymorphism. Right. Okay, now we'll discuss about what is overriding. So overriding allows the programmer to have a single method with multiple definitions. So the basic idea behind overriding is parent and child class can have same method signature with the different implementation. So that is the idea behind overriding. So in overriding, you are going to have a same method in parent class as well as the child class, and based on the object type of the particular class, the corresponding method is being executed. So in overriding, you are going to have a same method in parent class as well as in the child class. Right? So we will see how the overriding is being implemented with an example code. Now I am going to have a class person. So for the person class, I am going to have name as an attribute, and I am going to have an address as an attribute. So I have two attributes to represent a person, and I am going to have a method display. So inside this display method, I am going to print the information about a person. So here I am going to print name and address. So that is about person class. Now I am going to create one more class as a student, and the relationship here is the student is a person. So I can apply extends person. So here so here for some specific attributes I am adding it to the student. So every student will have some roll number, and every student may belongs to the particular department, right? So I have defined two specific attributes for the student class. Now I am going to have a display method. So the same method signature I am writing it over here, and I am going to print roll number as well as department number. Sorry, department name. Right. Now I am going to have another class to test student. or to test override. So test to override is a class. I'm going to have a main method, and here I'm going to create a reference for the student. Then I'm going to invoke display method of the student, right? Now what will happen over here is, inside the person class we have a display method, and inside the student class we have the same display method without any change. Am I right? So in a parent class we have a method name as void and display. In the child class we have a method void and display. So in method overriding, the entire method signature should be same. There should not be any variation in it. So but inside the person method we are trying to print name and address of the person, but in the inside student we are trying to print name, roll number and department of the person, right? And from the main class we are trying to invoke display method. We are creating object for the student class, so s.display directly invokes the display method which is there in the student class. So we will see the output of the particular code. So by default it is getting printed as null. So inside the student object I have to set I have to set roll number. So roll number, it is of a string type, so 10p101, and I'm going to set the department s dot department equal to CSC. Now I'm going to rerun the code. So now it is getting, roll number is getting displayed and the department is getting displayed, right? So which means that the display method which is part of student class is being executed. So why do we say it is a runtime polymorphism here is the object creation, right? So the object always created during the runtime of the program, not the compile time. So the type, so here we are taking the reference yes, right? So yes belongs to the type of class student, so which is only known at the runtime of the program, right? So during the runtime only your JVM will decides which display method is to be executed, either display method of student or display method of parent, right? So this decision will be taken during the runtime of your program or an application, so we call it as runtime polymorphism, right? So in overriding, everything is, the method signature is going to same. Apart from that, in Java there is an annotation to represent overriding. You can put it as @override, right? So I think I have made a mistake in the method name, so I'm changing it over here. So suppose if you want to manually represent this is the overridden method, then you can use the annotation. So this annotation tells the compiler that the following method is being overridden from the parent class, right? So if you want, you can use this annotation also. We call it as annotation. So annotations always, so this is a compile time annotation, so this always carries some information for the compiler, which means that the following method is being overridden. So in the overriding, we discussed about how it is being implemented in Java. Now we'll come back here. So in overriding, method name should be same. So method name should be same. Then return type should be same, right? So the return type should be same. Then argument should be same. So these are all the restriction when you apply or when you want to override a method in Java, right? And one more thing you should always remember is you can use less restrictive access modifier in overriding, right? So what is meant by less restrictive access modifier, right? So we will see from our demo code. So here, what is the access modifier we have given? So we have given no access modifier, right? It is there's a default access modifier. So here you can have, here also you can have a default access modifier, right? So in a parent class, if you have a default or no argument modifier, in your child either you can have no argument or some less restrictive access modifier. So we discussed about access modifiers, right? So in access modifiers we have something like public modifier, then we have protected, then we have no modifier, then finally we have private, right? So here private is more restrictive and no modifier is less restrictive than private, protected is less restrictive than these two, then public is no restriction at all, right? So whenever you try to override, you have to ensure that in overriding you are using less restrictive modifier compared with the method which is there in the parent class. So from down to up, the restriction will be lesser in the given order, right? So in person class, suppose if you have public for your method, public is a no restrictive modifier, then in that case during overriding you should use public, right? Then suppose in a parent class you have private, right? So if you have private, so private methods will not be inherited, so you can leave it apart. Suppose if you have no modifier, right? If you have no modifier, so if you take no modifier, what is less restrictive than no modifier? Either you can go with protected is very restrictive, public is no restriction at all. Suppose if you have no modifier method in parent class, during overriding either you can use no modifier or you can use protected or you can use public. So this is what you should remember when applying overriding